Welcome to the engineering class for March the 1st. I am recording today's class because we're going to be talking about the functional specification for a project that I want you guys to do next. And hopefully you guys understand there's a reason why I give functional specifications verbally rather than in writing. Because if I were to give you a written description of what I want you to do, well, basically I would have written your functional specification for you. And the whole idea is for you guys need to write it yourself. So I'm recording it. That way you can come back later and watch the recording and make sure that you got all the important stuff. And also there's at least one student who can't be here today. They're traveling right now. And so for Tatum's benefit too, I'm also recording it. But even if it wasn't for Tatum, I'd still be recording this. Before we talk about the new stuff, though, let me take a couple minutes and talk about the engineering specifications that were due last week. There's still a couple of you who have not turned in those engineering specifications. Guys, that counted as a midterm exam. So if you didn't do that, that's like not showing up on the day of a midterm exam and then wondering why you failed the class. It's kind of a duh. Of course, if you don't take the midterm, you're not going to pass. So that engineering specification that was due last week, that was the midterm for this class. Hang on a sec. Somebody just got here. Let me let him in. Mark and Tardy here. Okay. So if you were one of the ones that didn't do it, make sure you do it. I will have to dock you a few points because of it being late, but it's better to miss out on a few points than miss out on the entire thing. Okay. Now, last week, not only did you guys turn in the engineering specifications for the mechanical engineering project, but we also started into our next unit, which is the aeronautical engineering unit. And so we have talked a little bit about aeronautical engineering and what is it that makes airplanes fly. And most importantly, we talked about the things that make airplanes fall out of the sky. And we know that the number one reason for airplanes crashing is pilot error. But we didn't really focus at all on that. We focused more on the engineering design flaws that cause the airplanes to crash. So hopefully you know a little bit more about that. All right, so today we're going to start into a hands-on project, which is going to accomplish two goals. One goal is the superficial goal, and the other one is the deeper, more important reason. And you're going to find this is a pattern that I do all the time. So the superficial goal of the project that I'm going to assign you today is for you guys to make objects that can fly through the sky. And the goal is to make them fly as far as you can possibly get them to fly within some constraints, which I will explain in a few minutes. But making the object that flies through the air is only the superficial goal. It's not the deeper goal. The deeper goal last time, hopefully you guys remember, the deeper goal was to let you experience the engineering design process, all of the steps that engineers go through. You meet with the customer, you find out what the requirements are, you write up a functional specification, you do some brainstorming, and you come up with a long list of possible ways to approach it. And then you do some research and you narrow the long list down to a short list. You do a little bit more research and then you narrow the short list down to one final idea that's going to be your prototype. And then you make your prototype and you test the prototype. So all of that I just described is the engineering design process. And so the reason we did the project last time, yeah, launching pennies was the superficial goal, but the deeper goal was to learn the engineering design process. Okay, so today, the project that we're going to start today and we're going to work on for the next couple of weeks, the superficial goal is for you guys to design and build something that can fly through the air, and the farther it flies, the better, but you have to stay within certain constraints. But the deeper goal, Well, part of it is to reinforce the engineering design process, but we're going to be talking about a new concept, which is called design of experiment. And I don't want to go into too much detail right now because it'll take too long. And I want to focus on the getting the functional specification today. Today, the idea is that I'm going to pretend to be the customer. I'm going to sit down, I'm going to tell you what I want you to do, and you're going to write up a functional specification, and that'll be your homework tonight. Writing the functional specification is the assignment that you'll need to do and turn in before we meet next time. And then next time we meet, we're going to do some brainstorming. We're going to talk about all the different possibilities, and we're going to talk about something called the design of experiment process. And it's something that all engineers need to know. And so learning that is the deeper goal of the project that we're going to start into this week. But let's not go into that right now. Today, let's focus in on the functional specification. So what I'm going to do in just a couple minutes is I'm going to take off my teacher hat and I'm going to put on my customer hat. I'm going to pretend to be the customer and you are going to be the engineer. And now you're going to pretend that you work in a large team that has many, many engineers in it. But you don't want to send the entire team to meet with the customer. We talked about this last time. Hopefully you remember. I mean, imagine you're the customer and you're sitting across the table from a dozen different engineers, right? And they're all hitting you with questions. You're going to feel overwhelmed. You're not going to feel comfortable. And if the customer doesn't feel comfortable, the customer might not choose your company to give you the business. The customer might say, hey, I'm going to go give my business to another company. So it's important, you want to make the customer comfortable. And so rather than sending the entire team of engineers, we're just going to send one or maybe two engineers, and they will sit down across the table from the customer, and the customer will explain to you what the customer wants. And so it's your job to make sure that you fully understand the customer's requirements. And then you are going to write up a document that's called the functional specification. And you guys have now done one. So now you have a good idea for what it is. And so the functional specification is the document that describes everything about what the customer wants, what the constraints are that you have to work within, how the customer is going to test your prototype, and how they're going to score the testing, which things are really important and which things are just nice if type things. All of this is going to be contained in the document that you will write up. Because remember, the idea here is that you are the only engineer meeting with the customer. And you've got a team of other engineers that are going to help you, but they don't have the benefit of meeting with the customer, only you do. And so these other engineers on your team, they need to get all of their information about the customer's requirements from the document that you will write up. And so that's the functional specification. Okay, describes what is the job that needs to be done, how do you measure success, what are the constraints. Now there's one thing that a functional specification must not do. I'm hoping that you guys remember what that is. Anybody want to unmute yourselves and tell me, what is the thing that a functional specification must not do? Anybody remember? Nobody? Okay. Oh, I see a couple of you have raised your hands. Okay. Hang on. I can't see your hands raised because of the view that I'm using. Go ahead and just unmute yourself and just tell us.
Give ideas about the project and how it could be solved.
Okay, that's something it must not do, right?
Yeah.
Okay, very good. That is exactly right. Okay. And what's the reason for that? Alexander, what is the reason why you must not do that?
You don't want to like corrupt their thinking and fill their brain with your ideas.
Okay, excellent. Because you've got a team of very, very smart engineers. And they might have great ideas that you never even thought of. But if you word your functional specification in such a way that it suggests solutions, then these other people with these other great ideas, they might not uh, suggest their ideas because they think that the solution that you suggested is the one that the customer wants, when in fact the customer doesn't really care. um, so you don't want to limit their thinking, you don't want to corrupt their thinking. Okay, so that's what a functional specification must not include. All right. Okay, so I think we are ready now to to go ahead and into our exercise. So I am going to pretend that I am the customer. You are going to pretend that you are the one engineer from your team who is meeting with the customer. Now, one thing I do need to warn you about is I'm getting pretty old and pretty senile, and I might accidentally, wink, wink, forget to mention a few important things. So it's your job as the engineer to look at everything that I've told you and to think to yourself, are there some things that I need to know that the customer might have accidentally, wink, wink, forgotten to mention? And if there are some things like that, it's your job to pull that information out by asking questions. And so if there's something important that I forget to mention and you don't ask about it, well, shame on you. You need to be thinking about that. Okay, I think we are now ready to go. So I'm going to take off my customer hat, put on my, oh, I'm sorry, take off my teacher hat is what I'm going to take off. And I'll put on my customer hat. Okay, let's go. Thank you for driving all the way across town and coming into my office and meeting with me. I appreciate you doing that. Yeah, I have some requirements here that I am going to hire somebody to build this thing for me. And now it might be your company, but I do need to warn you that I am meeting with other companies as well. And so if they can give me a prototype that works better than your prototype, then I'm going to give them the contract and not you. So you need to make sure that your prototype is the winning version. Your prototype performs the best. And so whoever gets this contract, this is a multi-million-dollar contract. So this will be worth a lot of money. Now, let me switch hats again. Obviously, I'm not going to pay you guys money for this, but you do get points on your grade based on this. So whoever has the better prototype will get the more points. Okay, hat's back on again. So I'm back to being a customer again now. Okay, so here's the deal. I need your company to design an object that can fly through the air that is powered by air pressure. And so if it weren't for coronavirus, I have a special device at my school that it's a pressurized tank of air. And so what I do is I pump it up and I get a lot of high pressure air inside this tank. And then I have a special valve that can open and close instantly. It's called a solenoid. In fact, well, actually, let's not go into too much detail here. Basically, what it's going to do is when I open up the thing, it's going to send out a burst of air. And so the burst of air from my high pressure tank, that is the thing that's going to launch whatever it is that you build for me. And it's going to send it flying. And now, of course, once it leaves the launcher, then it no longer has anything pushing it. So then when it's flying through the air now, and I want it to go as far as it can possibly go before it hits the ground. So that's your goal, is to maximize the distance. So you're just going to get a short little burst of high pressure air to launch it. And then once it's in the air, it needs to glide for as far as possible. Okay. Now, if we were back at school where we didn't have coronavirus home restrictions, we would use this tank of pressurized air. Now, because we are at home, we are going to have to improvise a little bit. So let me show you what my launcher is going to look like. So I'm going to take a piece of paper and I'm going to roll it up tight. And I'm going to keep rolling it until it has the same diameter as a penny. I obviously like pennies a lot in this class. So the penny is a recurring theme here. So I'm going to roll this thing until the diameter is exactly the right size so that I can take a penny and I can put a penny inside here and it'll just barely fit. And I rotate it. I try putting the penny in horizontally and vertically and a couple different angles. So if it's perfectly round, then the inside diameter here will be the same as a penny. So once I've got it rolled to that level of tightness, I'm going to get out some tape and get a couple pieces. And so now what I have here is a rolled up piece of paper, just 8.5 by 11 paper. And this is going to be my launch tube. Now, because you guys don't have pressurized air tanks at your home, at least most of you don't, okay, your lungs are going to have to be the source of the air pressure. So what you're going to do is you're going to put this up to your lips and you're going to blow as hard as you can. So basically it becomes like a blow dart. So you're going to go, that is going to be the launcher. Now, this launcher is not ideal because one time you go, and then the next time you go, probably not the same amount of strength in each time. So, hey, nothing we can do about that. So we'll just have to try to make it so that each time we go with the same level of strength and, just do the best we possibly can. All right, so the launcher is going to be a rolled up piece of paper that has an inside diameter that's equal to a penny. But it's not really the launcher that I care about. What I care about is the thing that goes flying. So I have a template that I am going to give to you. In fact, I've actually already put it on Canvas. And so this template, when you go on Canvas, you'll find a link to something that when you print it, it's going to look like this. Okay, so it up here, it's got a bunch of words that you can ignore the words. They're just for decoration. The important thing is that there are 3 slits. In fact, tell you what, let's open up Canvas. And let's go and take a look at it. So this is physics. You don't want physics, at least not this year. Maybe next year you'll do that. Okay, engineering technology. And go to modules or go down to there. Okay. All right, now there's a couple things here that won't appear for you guys. For you guys, let me click on student view. Okay, so this is what it'll look like for you guys when you go in there. All right, so you'll see that there's a new assignment here that wasn't here before. If I click on it, it takes me to this assignment. So functional specification for the pneumatically launched flyer. So the thing that you are going to design, the thing that's going to fly through the air, it's pneumatically launched. The word pneumatic just means that it works off of air pressure. And so it's pneumatically launched and it's going to fly through the air. All right, and here's some instructions that we'll talk about later. This right here is the template. If you click on this, it will download. Well, okay, yeah, it's why is it locked? It shouldn't be locked for you guys. Okay, I'll have to unlock it. Sorry about that. So tell you what, let me get out of student view and let's go back into teacher view here. Okay, I'm not sure why it's locked, so I'll figure that out. Okay, so anyway, this is it. This is the template. So you can see it's a piece of paper. And so what you're going to do is you're going to print this out. Now, if for some reason you don't have a printer, then just look at the design here and you can make this yourself quite easily. All right, in the upper left side of the paper, there are these 3 lines here. These are important. The words here don't really mean anything. Don't worry about those. It's these lines that are important. So notice there's a line that says cut here, and then another one that says cut here, another one that says cut here. All right. And so let me show you how that works. Right. So you're going to take the paper that you're going to print out. You're going to take some scissors. And now where it says cut here, it doesn't extend all the way to the edge of the paper, but that's just because the printer doesn't allow me to print all the way to the edge. I want you to pretend that those dotted lines go all the way to the edge. All right, so what we're going to do then is I'm going to cut along there and just until the dotted line stops. And then I'm going to cut along here and I'm going to cut along here. All right. So I now have 3 cuts right here. Okay, now if you look at the bottom of the paper, it says start rolling here. All right, so what you're going to do is you're going to take the tube. So you have to make the tube first. I'm assuming you've made the tube. All right, and then we're going to take this paper and we're going to put it on the tube. And the end where it says start rolling here, that's what we're going to put on the tube. And then we're going to start rolling. And we're going to roll it around the tube. Okay. And it's kind of hard to do in the air. Let me put it on the table to get it started. Okay. All right. So now I'm just going to keep on rolling. Now, something interesting is going to happen when I get to those cuts. I'm going to watch what happens when I get to those cuts. You see how it kind of opens up there? And I roll a little more, and then that one opens up there, and then I roll a little more. And so these cuts now have opened up. They are going to be the fins on my rocket. All right, so I've got it completely rolled up, and so now the words Academy for Math, Engineering, Science, they appear on the outside of the rocket. Now I need to tape it. So I'm going to put a piece of tape on this end here, and piece of tape on the end up here, not on the very, very end. I don't want it on the very, very end. So I leave at least an inch there. And it would probably be a good idea. In fact, it would definitely be a good idea to have a piece of tape in the middle. So I'm going to put a piece of tape in the middle, right about there like that. Okay. All right. So I now have a rocket rolled around my launch tube. And I have these fins here. But these fins, I mean, you could leave the fins the way they are, or if you want, you could bend and crease so that the fins stick out perpendicular to the body. Okay, you see now the fins are a little more like normal fins. All right, so those are the fins on my rocket. Right. Now, the rocket is open on this end. So if I were to try and launch my rocket right now, it's not going to go anywhere because it's open on the end here. Well, that's going to be a problem. All right. So what I need to do is I need to fold that over. So I'm going to use my launch tube to kind of help me. I'm going to position it so that the launch tube protrudes out from the rocket end on the bottom where the fins are by about 1 inch, about the width of your thumb. Width of your thumb is about 1 inch. Okay. And so now up on the top here, so the rocket on this side sticks out about 1 inch beyond the launch tube. What I'm going to do now is I'm going to take my finger and I'm going to push this over like that. So you see it's, I pushed that in. Now, if you want to, you could take a penny and you could put a penny in the nose here. And we're going to talk later about why that might be a desirable thing. But there are people who believe that if you put a little bit of weight in the nose cone of your rocket, that helps it to fly farther. Now, there are other people who say, oh, not necessarily. I think it flies better if you don't put weight in there. That's one of the variables that I'm going to let you guys play with. Not tonight. I mean, your homework tonight is just do the functional specification. But on Wednesday, when we meet again, we do some brainstorming. One of the variables that we're going to look at to see if it's going to help it to go farther is going to be the question of, should we put some weight in the nose cone? And if so, how much? Because maybe instead of just putting one penny in the nose cone, maybe we're going to put 2 or 3 or 4. It might help it to fly better. So let's assume for a minute that we've decided we are going to put a penny in the nose cone. Okay, so we're going to put the penny right in there like that. And then, now that the penny's in there, okay, next thing we're going to do is we're going to fold down the rest of the rocket over the top of the penny. So this is a little bit tricky to do here. So I'm going to fold it like that. Sorry. The rocket is kind of collapsing here. So this is actually the most difficult part right here. Okay, so so I've got my penny right here. And now I'm going to fold this down. It keeps falling out. Okay. All right. So now I'm going to take a piece of tape, a longer piece of tape this time, and I'm going to tape over the top of my rocket. There we go. And I think I'll put a second long piece of tape there. And I'll put this one on going the other way. All right. Okay, so the end of my rocket is now closed off. All right, so my rocket is now ready to be launched. Okay, so here's the rocket on the launch tube. The end of the rocket is closed off. And so what I can do now is when I blow, it's going to go. So here goes. Okay, so now I have a rocket that is launched pneumatically that will go pretty far. Okay, now this is just the starting point for what I want you guys to do. What I want you guys to do is look at this design and see what could you do to make it go farther. So one question that we've already talked about is, if we put pennies in the nose, does that help us or does that hurt us? And if putting one penny into the nose is good, then maybe 2 pennies is better, maybe 3, maybe 4, you know? So do we want to put weight in the nose? Now, there are other things that you might want to modify. It's like, for instance, these fins. You don't have to use the fins if you don't want. And you can make if you do decide to use fins, you can go with different sizes. You can have really big fins if you want, or you can have really small fins if you want. And what about wings? What if instead of having a pneumatically powered rocket, what if we make it into a pneumatically powered airplane? What if we could maybe think of some way to take paper and attach it to the rocket so that now we have a pneumatically powered airplane? Is that going to make it go farther? Okay. And on these wings, you know, what shape should we make? How big should we make the wings? What shape should we make the wings? How should we attach the wings? You know, so adding wings, you would think would make it go better, but at the same time, when you add the wings, you're adding air resistance. And so if you have too much air resistance, that might slow it down. So maybe adding wings is a good thing, but maybe adding wings is actually a bad thing. It's up to you guys to figure that out. And there's all sorts of variables you can play with. The nose here, the way that I did the nose cone is just kind of a flat, blunt nose. You don't have to stick with the flat, blunt nose. If you want to make a cone, you can go with the cone. That's fine. So make it be a sharp cone. Maybe that'll make it go farther. Maybe it won't. I don't know. You're the engineer. I'm just the customer. What do I know? Okay. So there are all sorts of different things that you can do on your flyer, but it does need to launch the same way that we just talked about here, okay? You need to take your rocket, you need to put it on your launching roll, okay? And you need to launch it by blowing in here as hard as you can, and then off it goes. And so the goal is you need to make something that can fly as far as possible, and whoever's creation flies the farthest, you will get this multi-million-dollar contract. Except since you're students, it won't actually be a multi-million-dollar contract, but I will give bonus points to whoever can go the farthest. Okay, that was a long-winded introduction. So now let me ask, do any of you have any questions about things that I might have possibly forgotten to talk about?
Do you have to use the rocket template?
You do not have to use the rocket template. Okay, but it does have to be a rolled up piece of paper. Okay, and it does have to fit on the launch tube. So the launch tube, you have no flexibility about that. Your launch tube has to be made from a piece of paper that's 8.5 by 11, and it has to be rolled up so that the inside diameter is the same as a penny. And so put the penny in horizontally, vertically, okay? The penny has to just barely fit in there. So everybody has to use the same launch tube. But the flying device, as long as it's made out of paper, then you can, yeah, you don't have to use the template if you don't want. James, did you have a question?
No.
Okay, I'm sorry, it looked like you did.
I have a question. Do we have to, in our functional specification, do we have to explain how to make the rocket?
Remember, a functional specification specifically must not say that, okay? Because remember, the idea here is that you are going to go back to your team of engineers and you're assuming that they have a lot of great ideas, right? And you don't want to limit your thinking. So you must absolutely positively must not include that in your functional specification. Other questions? Paige, you got your hand up?
Are we limited to the materials that we can use?
Ah, yes. Oh, that's something that I accidentally, wink, wink, forgot to mention. That is extremely important. Yes, you are limited in the materials that you can use. Okay, so the launch tube has to be 8.5 by 11 piece of paper, just normal printer paper, normal weight. You know, the paper comes in various weights. There's like tissue paper that's really thin, and then there's printer paper, which is the normal stuff that we use. And then there's like really thick cardstock. Okay, so the launcher, just normal printer paper. Cannot be tissue paper, cannot be cardstock, must be 8.5 by 11. Now, the thing that flies, that you have a lot more freedom with. Okay, it can be made of any kind of paper that you want. Could be tissue paper, could be regular printer paper, could be cardstock, but it has to be paper. Okay, that's my only requirement. It has to be paper, and the size does not have to be 8.5 by 11. The template that I gave you guys is 8.5 by 11, but you don't have to do that. If you want to make it smaller, so instead of having a long rocket, if you would rather have a short rocket, if you think maybe a short rocket might launch better, you have my blessing to go with the short rocket. If you want to take two pieces of paper and tape them together so that instead of having a rocket that's 11 inches long, you want to have a rocket that's like 18 or 19 or 20 inches long, that's okay. That's allowed. If you think that will make the rocket fly farther, you have my blessing to do that. Did that answer your question? Anybody else have questions?
When is the due date for this project?
Okay, yeah, the due date is very important. we are going to do this project in steps. Tonight, we're going to do the functional specification. On Wednesday, when we meet, we're going to do the brainstorming, and we're going to talk about this process that I called the design of experiment. And so we're going to spend a couple days talking about that. And so I'm thinking that I haven't decided for sure exactly when the due date's going to be, because it kind of depends on how things go. But it certainly will not be due this week. I'm thinking that the earliest that I would possibly make it be due would be on Saturday at midnight, not this coming Saturday, but Saturday of the following week. But I might not even do that. I'm going to be a little flexible here, but for sure it will not be due at least until Saturday of next week. Anything else? I can think of a couple questions, a couple of things that I accidentally, wink, wink, forgot to mention. I would hope that you guys can think of them.
What is the price scale on this project?
Okay, that's an important question. Thank you for asking that. Okay, as far as price goes, I'm not going to put a dollar amount on it. As long as everything is made out of paper, that's all I care about. You can use as much paper as you want. I don't anticipate price is going to become a problem. One other thing that I should mention is that in addition to tape, you're going to need some tape as well. Wait a minute, I think that may have come out wrong. Let me try that again. In addition to paper, you're also going to need some tape. So you're going to have tape in order to roll this thing closed. If you decide to go with wings on your project, okay, you're going to have to figure out some way to attach those wings. Well, the only way that I will allow is tape. Okay, so paper and tape are the only things that I will allow people to use. So Lily, you've got your hand up there. You have a question?
Yeah, so my question is, let's say that the airplane drags along the floor. Do we measure where the airplane first land, or where the object first landed, or where it stopped?
Okay, that's a really important question. Thank you for asking it. I accidentally, wink, wink, forgot to mention that. Yeah, the place that you measure is where does the airplane first touch the ground. If it bounces, well, don't count the bounces. Is where does it first hit the ground? That's where you need to measure. And so you're going to measure from where you are standing to the place where it first touches the ground. Now I see that Griffey has typed a question into the chat box in a private message here. She's asking, can you use less than one sheet of paper? And the answer to that is a definite yes, you can. So remember how I said you don't have to have a rocket that's 11 inches long. If you want to make a short rocket, that's okay. So yeah, take a piece of paper, cut it up small. You can definitely use less than one sheet if you want. So Lily, I see you got your hand back up again.
Yeah, my second question was, do we measure it from the back of the object or from the very front of it?
Just whatever part of it touches the ground first.
Okay.
Now I see that Kian has just typed a question into the chat box, and he's saying, wait a minute, Mr. Hendricks, you said that you're only allowed paper and tape. He said, what about the penny? And you are correct, Kian. Thank you for pointing that out. So pennies are also part of the allowed materials. So paper, tape, and pennies. Those are the only things that you're allowed. Thank you for clearing that up there, Kian. Anybody else have a question?
Does cardboard count as paper, or is that excluded?
I am not going to count cardboard as, I'm going to say that cardboard is excluded. It has to be this type of paper.
Do you have to launch it launch it from ground level, or could you do it from like a second story window?
Ah, okay. Thank you. Thank you for mentioning that. That is really important. Okay, because if somebody launched it from a second story window, that would obviously give them an unfair advantage. Okay, so this is super important, and I'm very glad that you mentioned this because I accidentally forgot. Okay, in order for this to be fair, everybody needs to launch it from the same height. So let's all pick a number that we think is fair that everybody could use because some people are taller and some people are shorter. If we were to say, well, let's say that you need to do it from a sitting position and you need to sit so that you're, well, let's see, how far is that? That's about 4 feet. So Paige is suggesting 4 feet. I think 4 feet sounds reasonable. Okay, you guys, can everybody do that? So you do need to launch it all from the same height, and let's define right now, the launching height needs to be 4 feet. Now, the angle that you launch it at, that's up to you. I can tell you right now, see, because I know a little bit about physics, and it turns out that if you launch it at an angle of 45 degrees, that will give you the greatest distance. Now, if you really want to be finicky, that's not 100% true. It's a little bit complicated depending on how high you are. If you're launching it from the ground, then 45 degrees is definitely the optimum angle. If you're up above the ground, then it actually turns out to be slightly less than 45 degrees, but let's not get hung up on that. I mean, if you're launching it from 4 feet, then let's just say that 45 degrees will give you the best angle. But hey, if you don't want to do it at 45 degrees, hey, that's up to you. Any other questions?
How many tries do we have to launch the?
As many as you want.
Okay.
And remember last time when we did the penny launching activity, I made you do 3 consecutive launches and then you took the average of those 3. I'm not going to do that this time. This time, whichever one launch is your best. So if you want to launch it 100 times, and then just whichever one out of those 100 is the best one, that's the one to go with. And by the way, what I just said is a really important part of the functional specification. Make sure that that is included, because the functional specification not only describes what the thing needs to look like, but also how you're going to test the object. That's part of your functional specification. And what is the measure of success? That is an important part of the functional specification. Any other questions? Okay, not seeing any, not hearing any. And I can't think of anything that I have accidentally forgotten to mention that you guys haven't already asked about. So I think we're in good shape now. You should now have all the information that you need to write up a functional specification. Okay, so let's go in. Let me open up a sharing screen here. And let's go in and look at the assignment. Okay, hang on. Why is it doing this? Okay, it's being a little weird here. Let me go. Okay, here we go. All right. So when you click on Canvas, you will see this. And so we've already talked about much of this. Okay. So your homework tonight is just write up the functional specification. So I'm trusting that you guys remember what a functional specification is and what it is not. So make sure to only include the things that should be in a functional specification. Do not include anything else. So write that up and submit that as tonight's homework. Now, in your functional specification, you should include drawings to help the reader understand things more easily. And for instance, I would say that you should include a copy of the pneumatic rocket template. That should be part of your functional specification. Now, when you write it up, you can say that you're not required to follow this template exactly, but this template is a guide. It should be similar to the template. Okay, now, in order to get full credit, you must include all of the details that are important. When you guys wrote up your functional specifications for the penny launcher project, some of you did a great job of including everything that was important. A few of you did not do a good job of including all the important details. You left out some really important things. Now, if you left out a whole lot of things, then when you submitted it, I sent a message back to you saying, hey, this is unacceptable. You got to redo this. Others of you were kind of in between. You left out a few details, but it wasn't so bad that I sent you a note saying that you need to redo it. I reluctantly accepted it, even though it left out some important details. I am going to be a lot fussier this time. This time, if you don't include all of the important details, I am going to dock you points. So make sure that you include everything that is important. So I am not going to be as lenient this time as I was last time. Be thorough, or else you won't get full credit. All right, and then just submit that to Canvas, and it's due before class starts next time we meet. Any questions before I end the Zoom class? Not seeing any, not hearing any. Okay, so what I'm going to do is I'm going to let you guys go. Now remember, class is not over. We still have almost a half hour left of class. So what I want you to do with that half hour is I want you to get working on your functional specifications. I think that you should be able to write it up in a half hour. That should be enough time. So if you can get that done and get it submitted, then hey, you won't have any homework. You'll be in good shape. So if you want to go ahead and type bye into the chat box and then log off, that'll be okay. Now, just in case some of you have any questions that you didn't want to ask because you knew this was being recorded and you were a little embarrassed, what I'm going to do is I'm going to stop the recording. And so then we can talk without it being recorded.